Welcome you back to Global Education Zone, and in this video I'll be doing a continuation of a series of videos I've been doing on circle theorems. So circle theorems. And today I'll do a revision of the first 4 theorems or 5 theorems which we covered in previous videos. And the first of those theorems will be the one we talk about angle at the center is twice the angle at circumference. And basically something like this. When you have a circle, you have the center of a circle. Now, if you have something like an arc, let's say this arc from here to here, this arc AB, Now, this arc AB, if this arc subtends an angle, there's an angle in this arc, then the angle that is at the center here will be twice of this angle. That means this angle, if this angle is A, this angle will have A, will be E/2. So the angle at the center is twice angle at the circumference, or the angle at the circumference is half of the angle at the center. So these are the angles. This is the angle at the center, angle at the circumference. So that's the first theorem we talk about. Then the second theorem we talk about was that the fact that angles in the same segment of a circle are equal. So that simply means that if you have a circle like this, then and they are subtended by a chord, not an arc this time, a chord called AB. Now this is the segment of the circle, this is the minor segment, this is the major segment. Now if you have an angle in this major segment and you have another angle in this major segment, and note that these two angles, they must be subtended by the same chord. They are both subtended by a chord AB. What subtended means is that the base of the angles are formed by chord AB. Now the base of this angle ACB and angle ADB, the base of angle ACB is formed on this chord AB, and the base of angle ADB is also formed on chord AB. So that is what you call alternate angles. So if this angle is A, this angle also will be A, because they are angles in the same segment of a circle. So the third theorem we'll talk about, which is also a sequel to angle in the same segment of a circle, is the one that angle in a semicircle is a right angle. So basically, if you have a diameter of a circle, and any angle that's in that diameter will be a 90-degree angle, no matter what it is. So this angle in the semicircle, center O, this angle here is 90-degree, angle ACB. Then we also talk about cyclic quadrilateral, where we talk about the fact that in a cyclic quadrilateral, opposite angles are supplementary. So this is a cyclic quadrilateral. Is a quadrilateral. A quadrilateral is any plane shape with 4 sides. So this has 1, 2, 3, 4. Let's call it A, B, C, and D. Now this A, B, C, and D, angle ADC and angle ABC, they are opposite angles because they are facing each other. Look at, they are facing each other, these two angles. And angle BAD, angle BAD, and angle BCD, they are opposite angles because they are facing each other. So what that theorem says that this angle, when you add this angle and this angle here, when you add it to this angle here, it will give you 180 degrees. That's what it means. So today we're doing a continuation of those theorems, and we'll start all over again from tangents. And we'll talk about tangents. Now there are 3 theorems that we're talking about in this video on tangents. And the first one is that a tangent, when a line touches a circle, when a line is drawn to touch a circle, a single line drawn to touch a circle, that single line and is drawn to meet the circle at the single points. Something like here. This line AB, line AB, it meets this circle at the points X. Now, if the radius of a circle, when you draw a line from the radius to the point of contact, the distance, that angle formed is a right angle. So there's a proof for that. Let's show something to prove that. Now imagine you have something like this. Imagine you have 2 radii, another radii on opposite sides, and this circle center O, and this is P, and this is Q. Now, this PQ, let's complete this triangle, something like this. In this PQ now, this angle here is equal to this angle here. Why? Because they are isosceles angle. Base angles of an isosceles triangle are equal. So this is an isosceles angles, and these are the base angles, and they are both equal. This one here and this one here, they are equal. So what that means is that as we progress downward, if we change this one, if we change it to here and here, they will still be equal, right? This one is, they are still, because these are equal radii. This radius is equal to this radius. That's an isosceles triangle. So that means if this angle is equal to this angle, then the exterior angle, the angle outside, will also be equal to the opposite exterior angle. Because angle on the line is 180. So if this one is x, for example, this one will be 180 minus x, and then this one also will be 180 minus x. So that means these outside angles are equal. Then if you continue going downwards until you get to until these two lines, until they merge. If they merge, those two exterior angles will also still be equal. And if they are equal, that means they will be the same. That will, if one is x, the other one too will be x. X plus x is equal to angle in line is what? 180. Right? So that means 2x is equal to 180. So that means x is what? 180 over 2. That's 90 degrees. So that means any one of this angle, when a line touches a circle at one point x, any one of this angle on either side is 90. This is 90. This angle is 90. This angle here is also 90. So that's a simple explanation for this theorem. So we're doing a calculation on this explanation later on. But before that, let's move on to the second theorem. So this theorem is like the background of all theorem on tangents. Let's walk as fast as we can. So next, we'll be talking about second theorem. That will be this theorem that when you have a line, when you have a point after the circle, if you have a circle like this, and you have a point after the circle point, let's say point A, and from this point there are two tangents. If two tangents are drawn, this is a tangent and this is another tangent. Now we said the tangent touches the circle at one point, abi? So this point touches at point X, and this touches at point Y. That means what this theorem is saying is that these tangents are equal. Now this is center O, right? So we are going to prove that these tangents are equal. First of all, to prove that, let's join this to this point Y. Let's join this to Y. Let's join this to X. Then let's join the middle too. So that's our construction. And if by the way you use new general maths, you'll be able to see this proof in a more detailed and organized form. But I'm just rushing through it so you can easily get the hang of what we're talking about here. So now, let's continue. Now, we are going to prove that this one is equal to this one. First of all, let's look at this. We're also going to prove that this angle is equal to this angle too. Now, this OA, OY, you agree with me that OY is equal to OX. You have to agree with me. Why is that? Because they are both radii. They are both radiuses. Right? This OX is a radius, OY is a radius. You also agree with me that OA is equal to OA. That's a single side. OA is equal to OA. Right? So, and lastly, you also agree with me that this angle here, angle OXA, will be 90 degrees. Why is that? Because when a tangent touches an angle, as we proved here, this angle here is 90 degrees. So these angles, the angle between the radius drawn at the point of contact and the tangent is 90 degrees. So the angle between the radius drawn at the point of contact, OX, and the tangent, that's AX, will be equal to 90 degrees. So, and it still applies here, OYA will also be 90 degrees. So that means this angle this triangle OYA and triangle OXA, they are both right angles. So that means we can safely say that if this one is equal to this one, OA is OA, OY is equal to OX, then OXY is OXY. OYA is OXA. So that means this triangle will be similar. Why would they be similar? Because they have their right angles equal 90 degrees. They have their hypotenuse equal. This hypotenuse, they both share hypotenuse, and they have one side equal. Which side? OY and OX are equal. So this triangle are similar. That means for similar triangles, all their angles, all corresponding angles are equal. That means triangle OYA and triangle OXA. So triangle OYA is similar to triangle OXA. That's what this means. So that means angle OYA will be equal to angle OXA. That means angle OAY will be equal to angle OAX. OAY will be equal to angle OAX. Then lastly, we can also prove that angle AYO is equal to angle AXO, and that's OYA. Yeah, that's correct. We can also say angle YAO. Yes, YAO is equal to angle XAO. YAO and is equal to angle XAO. And the reason why we are able to bring out these similarities is because these triangles, they are both similar. In fact, let's say they are congruent. They are congruent because they are congruent triangles. Apart from similarities, they are congruent. So these are the conditions for congruency. So that means this angle, this line line AY must be equal to line AX. So that means AY is equal to AX. AY is equal to AX. So that means this a tangent drawn. If two tangents are drawn from the same point outside the circle, that means those two tangents will be equal. So this I've been able to prove 4 things right from here, right? Now let's use this proving to solve an example on tangency. Let's use it to solve an example. Let's solve something now. Let's do something. So an example. So now I will draw a diagram here and I'll prove some things here. So this is New General Mathematics Book 2. This is for SS2. Just in case you might want to review some things. And this is Circle Theorems, page 132. Page 132, just in case you might want to review. Now I'm going to do an example now. So we have a tangent. This is the point outside T, and then we have a tangent drawn to the circle from this point outside, and then we have another tangent drawn to the circle from this point T. Then we have diameter of the circle. We have if this is A and this is C, then we'll now draw a straight line to connect A and C. Then we'll now draw the diameter. Okay, diameter is B, it's AB, and this is center of the circle. Center of the circle is O. Now, we said AB is the diameter of the circle, right? Of the circle ABC, good. Center O, good. TA and TC are tangents. This TA, and this is TC. They are tangents drawn from the external point T. Now, if ATC is 2x, if this one is 2x, show that BAC, we want to show that this angle here is x. So we want to show that BAC is x. So now let's begin improving. Now, if we join this one to this one, if we draw a line to join this one to this one, and we now join, if we draw another line to join this O to this one, to the middle, just as we did here, we join the O to the external point. So, because we say that angle YAO will equal to angle XAO. So we can also compare it like ATO will equal to angle CTO. That means this one will be x and this one will be x. They are both x. Since everything is 2x, so if you divide by 2, you get x and x. And this is x and this is x. So let's move on now. Now this is diameter, right? This BA, AB is the diameter. Now this angle here, this angle BCA is formed at a semicircle, right? And we know the angle at a semicircle is 90 degrees. So this angle here is 90 degrees. Angle BCA is 90 degrees. Angle BCA is 90 degrees. And the reason for that is that angle in a semicircle, angle in a semicircle. Now, the next thing we're working on now is, now if this is x and this is x again, this angle here will be what? This line and this one, from here will prove that these tangents are equal, right? So this line will be equal to this one, right? So that forms an isosceles triangle. So this angle will be the same thing. So let's find what they are. So now let's move on to say this ATC, angle ATC plus angle TAC plus angle TCA is 180. And why is that? That's because angles in a triangle is 180. Let's give you a reason. Angles in a triangle. So when doing your work, always endeavor to give your reasons like this. Now ATC is what? ATC is equal to TAC, Abi. Let's call them ATC. Let's call it 280 2 TAC. Because TAC is equal to TCA, right? Let's call it 2 TCA. So ATC is what? Is 2x. 2x plus 2 TCA. TAC. 2 TAC. Let's use TAC. Because we want to prove with TAC. 2 TAC is what? 180. So that means 2 TAC what? 2 TAC what? Will be 180 minus 2x. Minus 2x. So TAC will be what? 90 minus x. Why divide both sides by 2? Now that means this angle here is 90 minus x. And so is this angle 90 minus x. Because they are equal, isosceles triangle. Now look at this whole angle BAT. This is a tangent, right? Everything here on BAT is what? 90 degrees. And BAT is BAC plus C plus TC plus TAC. Right? So BAC is what? TAC plus what? BAC is what? 90 degrees. Because angle, and why is that? The reason is that angle at a tangent you get it now. So now TAC is 90 minus x, right? So let's cross it over. So BAC what? Over what? 90 minus x. Let's put it in brackets. So when we open our brackets, we have minus here. 90 will cancel minus. 90 will cancel 90 here. And this minus will times the minus. That will plus. That's BAC is what? Plus x or x. So this angle here, we've successfully proven that this angle here is x. So that's the proof for such a question. So we just applied it. We applied two theorems. We applied the theorem that the angle drawn at the center at a point outside the circle, it forms two tangents, and those tangents will be equal, just like here. And then this angle will be equal. This angle is 90, and this. When you divide the angle to meet the radius or the center of the circle, this angle formed will be equal. So these are theorems. You can revise them on your own in your textbook. So let's move to the last theorem for today, which we'll be talking about, and that will be angle formed by tangent. So now this theorem states that. So we'll also do an example after talking about this one. So but this theorem states that if this is a circle, and then these are chord, right? And this is a chord. Now, chord AB. If we form a chord, Actually, these are tangents, and it means our circle at point x. If we form a chord at the point of contact, now we form a chord xy at the point of contact. Then the angle in the alternate segment. And what is the angle in the alternate segment? These are an angle in the alternate segment. So angle in the alternate segment is the angle that is not in this segment. This is the segment of the chord, and this is the alternate segment. So this angle A will be equal to the angle between the chord and the tangent. This one will be A. That's what it's trying to say. Now let's prove that. So our proof, we will use something like let's make this the center of the circle. Yes. Now if this is the center of the circle O, you will agree with me that this angle here is the right angle, right? So let's not give our answer yet. Let's just show the theorem. Now I want to show that this angle is equal to this angle. I want to show that this angle here is equal to this angle here. So now this is our center of the circle, right? And this is 90 degrees. Now let's call this one x. Now if this x, this one will be 90 minus x. 90 minus x. Why is that? Because this one plus this one will give us 90, and the angle between the tangent and the radius is 90. This angle here is 90. This is 90 minus x, this one will be x. So if it is 90 minus x, this one will what? 90 minus x plus 90 plus what? This is what? X. Let's call this one c. xcy. xcy is what? Is equal to 180. And why is that? That's angle in a triangle. Angles in a triangle is 180. Sum of angles in a triangle. So that means we can say 180 minus x plus xy plus angle xcy is equal to 180 degree. So 180 will cancel 180 here. So that means xcy. When you move x to the other side, xy will be equal to x. So this angle is also x. So we've successfully proven that this angle x, therefore angle bxy is equal to what? Angle xcy. xcy. So that's angle in the angle form at the tangent is equal to angle in this alternate segment. So now let me solve a question on that to illustrate that, and I'll be solving a jam question today to illustrate that. Actually, I guess I'll be solving two. Let's quickly get the question. So this is jam question, and this is 2010 question 28. So we have a diagram here. This is jam series. We have a diagram here, and we have that this is a circle, and this is a tangent here. This is something center of the circle. This is 25 degrees. This is center of the circle O, and this angle is x. This is S, and when you draw a straight line, it forms a triangle. This is S, this is R, and this is T. Now the question asks us that find the diagram. In the diagram, find x. So we have to find x in the diagram. Now this is x. X is T. Let me see, what is the other angle? Angle x. So this is a tangent. This tangent means the circle at T. Now they said to find x, right? Now the first thing we are going to do is we are going to look at this triangle first. Now this is an isosceles triangle because this angle here, because this one is diameter, right? Okay. I'm trying to diagnose the question. The question says find x, right? Okay. Okay, now this is a diameter, right? Now this angle at this form at the semicircle, because anytime you have a diameter, you want to form at the at the circumference we called an angle in a semicircle. So this angle here will be 90 degree. So you can say angle RTS, angle RTS is equal to 90 degree, and that's angle in a semicircle. Angle in a semicircle. Now we can looking again at this circle. What's this one? This one what? So now this triangle RTS, sum of angles in the triangle is 180, right? So we can say this angle 25 degree, plus what? This one angle RTS, that's 90 degree, 90 degree plus angle what? Angle RST, RST is what? 180 degree. And why is that? That is because angles in a triangle, sum of angles in a triangle is 180 degree. Now that is RST will be equal to what? 180 degree minus 25 minus 90 degree. That what? 180 minus 90, that's 90 minus 25. 90 minus 25 will give us 55 degree. I'm sorry, 65 degree. Yes, 65 degree. So answer here is 65 degree. 5 degree. Now look at this angle this angle X. Now look at it, this is a tangent, right? So this angle because we angle in the alternate segment, and where's the alternate segment? This is the alternate segment. So this angle here is the angle in the alternate segment, and this is RST. So angle RST will be equal to angle X. So angle X here is what? 65 degree. And why is that? The reason for that is that angle in the alternate segments. So that is as far as we can go in this video on tangent.